Through this lesson, we are going to look at humidity and in particular issues surrounding water vapor. The substance of water has three well-known states or phases. The solid state called ice, the liquid phase, simply called water, and finally the gaseous state called water vapor, which of course we usually cannot see. Dry air is defined as a body of air with no moisture content at all. In reality, this does not occur in the atmosphere. When any amount of water in vapor form is present in a body of air, the air is defined as being moist. Looking at the diagram, we can see a parcel of dry air with no water vapor and a moist parcel of air with water vapor. The presence of water vapor in the atmosphere has a major impact on the behavior of air. However, the concentration of water vapor varies greatly, both in space and time. It is generally found in such small quantities that it is not even listed as a trace gas, but yet its presence impacts on us greatly. Without it, there would be no weather. Uniquely, water can be found in the atmosphere in all of its three states. One of the major impacts water has on our atmosphere is when it changes from one phase to another. During these changes, energy is transferred in different ways. This energy is known as latent heat. Latent heat, or hidden heat, as it is sometimes called, is the quantity of heat released or absorbed when a substance changes from one phase to another. On the way up from the solid state through liquid to gas, latent heat is absorbed, whilst on the way down from gas to solid through liquid, latent heat is released. Let us see what happens when we change state from solid to liquid, in other words, during melting. As we heat the solid, it will start to melt. Energy, in the form of latent heat, is then absorbed from the surface and then stored in the liquid. As we saw latent heat being absorbed into the water when it changed state from solid to liquid, we shall now see the same occurring when we change state from liquid to gas. This is known as evaporation. During evaporation, latent heat energy is absorbed from the surface and stored in the water vapor. Evaporation from a water surface will occur at any temperature above absolute zero, minus 273 degrees Celsius, but the rate of evaporation increases as the temperature increases. This is because as temperature increases, the water molecules have more energy and are more likely to change state. Looking at the diagram, we can see that evaporation from the water surface is adding water vapor to the air. However, for a particular temperature, there is a maximum amount of water vapor a body of air of unit volume can hold. So, as evaporation continues, the air above the surface will contain more and more water vapor and may eventually reach its maximum holding capacity. When this is reached, evaporation will cease. The air above the water surface is said to be saturated. It can hold no more water vapor. To recap then, if we continually add water vapor to a parcel of air, it will eventually become full or saturated. We have established that one way we can make air saturated is by evaporating water into it until it is full of water vapor. However, there is another method of achieving this. If we cool air down, the space between air molecules decreases, and therefore there is less space for water vapor to fit. The opposite is true when we warm air up. Warm air has more spaces between the molecules and can hold more water. So, if we have a parcel of air that is partially filled with water vapor and then cool it down, the air will eventually reach a point where it is holding as much water vapor as it can. Now the air has become saturated. Condensation is the reverse of evaporation. It is the phase change from vapor back to liquid. If you remember, the water vapor had a lot of stored latent heat. So, when it then condenses and changes into water again, it releases this heat back to the surroundings. Again, we can appreciate this when we have been burnt from steam. The steam is hot anyway, but when the steam condenses onto our skin, even more heat is given to us, and we feel even more pain. As we have seen, condensation is said to occur when water vapor changes state into visible water like dew, clouds, and fog. But this process is actually quite complex. For condensation to occur, we need minute particles in the atmosphere for the water to form around. These are called condensation nuclei and mainly consist of salt particles put into the atmosphere over the sea. There are other condensation nuclei, such as pollutants from industrial sources, virus, fires, or volcanic eruptions. If no condensation nuclei are present, air will tend to become super saturated and hence have a humidity of greater than 100%. When the temperature of water drops below 0 Celsius, it generally begins to freeze. I change from liquid to solid. Remember from earlier in the lesson that this involves the release of latent heat. Here we can see the heat being given up to the surroundings. In a similar manner to condensation, freezing usually requires the presence of particles. In this case, they are known as freezing nuclei. So, as the temperature of the droplet falls, if there are particles in the water, the droplet will freeze.